Good evening. My name is Hayden. My team are Alex and Rachel. We're all engineering students here at UQ. Recently we've been focusing our efforts on new and novel methods for harnessing renewable energies. Through our research phase we discovered that there's more than 100 countries that have some form of feed-in tariff policy. However, with more and more people migrating to cities and into high-rise living, they aren't able to capitalise on their nation on these economic incentives. In Australia alone there are more than 2 million people living in some form of vertical accommodation. So this illustrates that there's a market and a need for small-scale energy generation. So what we did is we looked at what renewable energy sources are readily available to people living in the city, and we determined that there's plenty of wind in the city. However, traditional wind turbines are cumbersome and they're unable to collect wind from every direction. This is a bit of a problem since wind in the city is erratic and turbulent at best. So to overcome this problem, we developed the Powersphere. It's an omnidirectional wind turbine that can capture wind from every direction and generate electricity. This allows its customers to capitalise on these feed-in tariffs, offsetting their rising cost of living and reducing their carbon footprint. So how does it work? Well, vents have been positioned across the profile of the device to maximise wind intake. Wind can come from any direction, vertically or horizontally, or a mixture of both, it doesn't matter. It will cause the turbine to spin unidirectionally on a single axis and generate electricity. The vents have large openings with smaller exits to create a pressure difference. This has allowed us to optimise turbine spin. So where's the tech at the moment? Now we've developed a prototype. I know it's not pretty, but it's functional. It's a proof of concept that a truly omnidirectional wind turbine can be created and function as intended. We started off with testing in a controlled setting with a blow dryer. This is so we can manipulate wind direction. From there we optimised internal vent architecture and moved on to testing in environmental conditions. So we put it on an apartment balcony and we watched it spin. I know I've been talking a lot about apartments and high-rise living, but it should be noted that the Powersphere can function anywhere that there's wind. It's not limited in application to the side of a building. It can be put in a rural area, the side of the road. As long as there's wind, it will function. Our next step is to 3D print our final device with polylactic acid. We chose PLA because it's cost effective. We can produce a turbine for under 30 Australian dollars. It's a lightweight option, so the Powersphere will come in at under 1.3 kilograms. And it's environmentally sustainable. PLA is derived from renewable resources, so it's got a low embodied energy. And we've calculated that within the first year of operation, it will become a carbon positive system. We've also just started the process of applying for patents to protect our IP. So some of the saleable features of the Powersphere to allow it to appeal to the largest market possible is scalability. So although it's intended for small-scale residential use, because of the simplicity of its design, it can easily be ramped up into more large-scale commercial applications. It has a good energy output, so even with conservative wind speeds and low rebates, it can produce more than 20% reclamation for its customers on the initial value or initial price. It's lightweight and modular, so as I said, it comes in at under 1.3 kilograms, so this allows it to be easily transported or fixed to any surface without causing any damage. Low maintenance. Because it functions on a single axis of rotation, it doesn't have any steering involved, so there's a lot less maintenance than traditional wind turbines. As I mentioned, we'll be manufacturing it from PLA, which is a renewable resource, so it'll become carbon positive in time. It's efficient. So throughout our testing, we noted that it could function with wind speeds below 2 meters per second, which is a lot less than traditional wind turbines. And it's cheap. We can make it for under $30. This allows it to be market or competitive in the marketplace, and it also allows it to be a viable option for a large demographic. Thank you.